Welcome to day 8 of Advent of Code. Today we will be helping elves connect some junction boxes together. So these boxes are points in 3D space, and we are supposed to connect them with as short as possible wires. So we will be taking the distance between the points in the 3D space and finding the ones that are closest together and connecting them. And our goal is to kind of continue connecting the boxes until we reach some specific conditions. So it's supposed to be after connecting 1000 pairs of junction boxes together that are closest together, we will see what's the size of the 3 largest circuits that we kind of create. We kind of create separate circuits of boxes that are interconnected, and these circuits are what we are calculating the sizes of them. We will be multiplying together to see how many are what's the total multiplied size of those. So let me take this sample input, even though there is just 20 of them. So I think the conditions should be different in this case. So in this case, we should be 10. Yeah, we have 10 connections. We create 11 circuits, and then we multiply those 3 together. Yes. So let's do this something like this. So I will create so I will take the sample input, put it here, and now if the test data will read in the lines of the input, and if lines count, length is less than like 50, then we will have our target, some kind of target connections will be 10. If its lines length is less than 50, then we will be connecting 10 connections, otherwise 1000. So something like this. And now we will be reading in those points. So boxes is going to be new list of point 3D. So this is our helpful struct that we created in previous years. It just contains X, Y, and Z coordinates. So you can see it's just a very simple struct with some additional operators that we can use to add those together. And I think is there a distance from each other? Manhattan distance, but we don't have a distance. So yes, we should have also in the double distance to another one. It's squared root of square of distances between like basically Euclidean distance, basically nothing else. So we just take that as the distance, and then we do so we take our lines, we split each line. What is that? Read all lines. So we split them by comma, and that gives us the distances, and the numbers are reasonably large, so we can keep integers there. So we need count. Okay, so we read in the lines, and we read the boxes, and now we need to calculate the distances between each pair of boxes. So distances. So we'll do something like we'll have or we don't have to put in field. We have private, or we should have distances between. It's going to be a dictionary of point 3D, point 3D. And it's going to be a double. So we just calculate distance between each pair of points. So for each for each our box in boxes, box 1, box 1 in boxes, for each box 2 in boxes, and we calculate the distance. So and actually we don't have to calculate unless we already calculated that. So let's do, instead of 4 and do box 1, let's count, and we do 4 box 1 plus 1, box 2, and like that. And we store, the distance is the same when going from box 1 to box 2 and from box 2 to box 1. So we don't have to calculate both directions. We just store it for both the same. So we have distances between the boxes. And now what we can do is, so actually if we store it like this, we will have the distance separate. So these are all the distinct distances. So distinct distances, and we will have a list that will have 0.3d, 0.3d, and double distance. So this will store us box 2, box 1. This will store for us the distinct distances. So the ones, these are all the distances, so we can easily check for the distance, but we can also store distinct distances, and we will store it here. We add boxes, box 1, box 2, and the distance between them. And now we have the boxes with all the distances. We can now sort the distances. So we will do exactly this. We will sort by distance. So we have the distances stored by the smallest distance. And now we will need to connect them together. So initially, we will have all the points, all the boxes in each separate circuit. So circuit is going to be a list of 0.3d. So initially each will have its own circuit. And for each box in boxes, we will just create a separate circuit for each box. So now they are each in its own circuit. And we will now do something like this. So for distance id equals 0 until we have the target connections. And we will take the distance that's nth smallest, so id, and when we connect the circuit, so the connection will happen like this. We need to find where that, we need to find a circuit where the box is located. And we need to find that how. So actually we should have a dictionary of 0.3d, like a mapping each box to its circuit. So we will match it like this. We'll have a box and it's connected to its own circuit. And now when we connect those two, we'll have circuit 1, circuit 2. Then we check which is smaller. If it's not the same circuit, we will merge them. If it's already in the same circuit, we kind of already have the same connection there, so we don't have to care about that. But if we don't, then we add range, we will add it to the circuit, and then we can return, we remove the circuits, so circuits, or actually we don't have to remove it, it's going to be removed automatically, like it's not going to be in this dictionary, that list will be gone from the references. So we will add all the circuits from the second box to the first box, and then we will just set the circuit for each box in the second circuit's connection to be equal to our new list. So that's it. So now when we are done with all this, we can order. We need 3 largest circuits, I think. Yes, 3 largest circuits. So largest circuits equals circuits order by select. We will select the value, we will do distinct, and we will order by, and it's going to be ordered by c dot count and descending. We will we order by descending size, and now we take just the first 3. So we'll return largest circuits 0 dot count, or 0 times, it's going to be times, or no, it's going to be multiplying together. Yes. Okay. So largest circuits 0, largest circuits 1 times largest circuits 2, something like this. But it's complaining because we didn't do take 3 and 2 array. Okay, so we should be having the right result here. We select just the value dot count. We can do value dot count, or we can, well, we need to do like this, or by descending. Then we can do select c dot count, and now let's make it multiple lines so it's more readable. So we first take distinct circuits, then we order them by their count, then we just select the count, take the 3 biggest, and we put it into array, and then we have exactly the calculation that we expect, and we take that product to string, and that's it. Hopefully this will be enough. So right, let's do 8, number 8. We run it against the test data. It's 40. It's 40, and it's 40 in here. So that's promising again. Let's see what happens if we run it against our input file, and it's this number. It's not really efficient solution, but hopefully it's the correct one as well still. Yes, it is. So we have the first part solved, and now let's continue to the second part. So in the second part, we figure out that we have enough extension cables, and we need all the boxes in one large circuit. So we need to continue connecting the junction boxes until we kind of connect them all into one big circuit. So when we connect them all, we need to find the circuit that kind of connected the final produce the final connection, and then multiply the x coordinates of those two boxes. So this should be an extension of what we already have here. So I will take our current solution, put it here, and try to use that. So we'll do while true. So for actually, we can do for, sorry about that. We can do for without any condition of stopping. So we continue for each distinct distance, we merge. And when we merge, we check if we already merged everything. So if circuit 1 count equals boxes dot count. So if you already merged everything into one circuit, then this was the connection that kind of caused it. So we can return box1 dot x times box2 dot x, and that one is as a string. So it should be a multiplication again. Yes, we have to check that, but multiply together x coordinates, yes. So this is the adjustment. We'll see what happens. With the test data, we get this number, which is correct. So we'll see what happens with input file. It could be too large, but it's giving us something, so we'll see. And that's correct. Okay, so the second part was actually quite easy, surprisingly easy. So hopefully, yeah, it was surprisingly easy. Actually, usually the second part is much more complicated, but this one was just a simple adjustment to what we already had. So that's nice. Okay, so thank you for joining me for day 8 of Advent of Code, and I will see you next time.